Okay, here we are with the third example, finding derivatives of trig functions. And you can see in this example, f of x equals sine x times secant x, all divided by 1 plus x tangent x, that we actually are going to be dealing with a quotient rule to help us find this derivative. So let's get started. F prime of x. So in the quotient rule, we know that it is the bottom, 1 plus x tangent x, times the derivative of the top, so d dx of sine x secant x, minus the top, sine x secant x, times the derivative of the bottom, 1 plus x tangent x. All divided by the bottom squared. Looking like this. Okay. Now, I hope that I have enough room on this board. I may have to try to write a little bit smaller, so maybe you can zoom in. I'm not sure. We're not going to do anything with 1 plus x tangent x yet. There it is. And I need to do the derivative of sine secant. And this is going to require a product rule. So we're actually going to do a product rule inside of a quotient rule. So this is going to be then sine x d dx secant x plus secant x d dx sine x, okay, minus sine x secant x, and then we need the derivative of this other one, and this one's going to require the derivative of 1, and then also another product rule. So d dx of 1 plus, and then a product rule for x times tangent x. So that's going to be x d dx tangent x plus tangent x d dx x. And of course, this is all divided by 1 plus x tangent x squared. Okay. So now we'll actually go about taking the derivatives of all of these things, and after that, it's just really some simplification. And I say that like it's easy, but there are some little things we have to talk about in there. So we're going to have 1 plus x tangent x. Now, I will say as I'm working through this, you'll notice that this is going to get a little bit tricky in here, and you need to be careful to make sure that you are writing out all of the work. Try to take it one step at a time. Don't try to do too many things at once. And try to be neat about your writing. Don't try to squish all of this in one line of paper. Because it will make your life easier in the end. Because, for instance, if you miss, like writing the x with the tangent x, it's going to throw the whole problem off. So then in this first bracket, we're going to have sine x times the derivative of secant x. And the derivative of secant x is secant tangent. So we have secant x, tangent x. Okay, plus secant x times the derivative of sine, which is cosine. So that's that first set of brackets there. Then we have minus, still have sine secant. And then in this bracket we have the derivative of 1, which is 0, plus x times the derivative of tangent. Well, the derivative of tangent is secant squared. So we have x secant squared plus tangent times the derivative of x. Well, the derivative of x is just 1, so we end up with just tangent x. And of course, this is all still divided by 1 plus x tangent x squared. Okay. All right, we can do some manipulation now. This is where we kind of start to think about what can happen. So kind of as an aside, and you might put this like even in the margin of your paper, if I think about this expression, sine times secant times tangent, and I rewrite that as sine times secant, which is 1 over cosine, times tangent, which is sine over cosine. Okay, I really end up with sine squared over cosine squared. Okay, that's sine squared over cosine squared, which is tangent squared. Okay, so that is this part here. Okay, and if we think about secant cosine, secant is 1 over cosine times cosine is going to give us cosine over cosine, which is just 1. So this part of the expression becomes 1. Okay? All right, I'm going to have to erase some up here at the top. Maybe all the way down to this line. Okay, so what we end up with now, f prime of x, which is still 1 plus x tangent x. Now in this bracket, I've now simplified this expression and this expression to give me tangent squared plus 1. Okay, minus, we have a couple of other little things to think about. Here we're going to have still sine secant times x secant squared x plus tangent. And of course, all still over 1 plus x tangent x squared. Okay, again, let's recalling our trig identities that we used earlier. We have 1 plus x tangent x. Tangent squared plus 1 is secant squared. So we're going to make that substitution. And then we're also going to go ahead and distribute this sine secant to the terms inside here, keeping in mind that we have a minus sign here. So when I do negative sine secant times x secant squared, I get negative x sine x secant cubed. And when I do negative sine secant times tangent, I get negative sine secant tangent. All over 1 plus x tangent x squared. Now this sine secant tangent that we got over here is, we just talked about it, right? This whole thing is going to actually reduce to, and it was down here at the bottom, tangent squared. Okay, so that's going to become tangent squared. And we're almost there. We're getting close. All right, so we're going to now go ahead and distribute this secant squared into this parentheses. So I'm going to end up with secant squared plus x tangent x secant squared minus x sine x secant cubed minus tangent squared, all over 1 plus x tangent x squared. Okay. All right, I'm going to erase this part now as we continue on. And I'm going to do a little bit of rearranging of terms. I'm going to call this secant squared minus tangent squared. Okay. Secant squared minus tangent squared, so that's this term and this term. And then I'm going to take a look at what I can do with this x tangent x secant squared x and the x sine x secant cubed x. So again, this is something you might want to consider in the margin. That's x times tangent, which is sine over cosine, times secant squared, which is 1 over cosine squared. Okay. This one is going to be x times sine x times 1 over cosine cubed. And here's what you should notice at this point is that this is x sine x over cosine cubed. This is also x sine x over cosine cubed. If you hear that beeping, it's because my children's frozen pizza is ready. I have to grab it out of the oven really quickly, sorry. So when those two things cancel and go away, it's going to leave us on the top with tangent or secant squared minus tangent squared. So look back at your trig identities that we talked about at the beginning. Oh, excellent. And there's my smoke alarm, so sorry. So these two things end up canceling each other out as we've shown here, right? X sine x over cosine cubed minus x sine x over cosine cubed go away. So we're left with secant squared tangent squared over 1 plus x tangent x squared. Okay. And again, going back to our identities at the very beginning of class, we said that tangent squared, or 1 plus tangent squared was secant squared. And all I have to do is subtract tangent squared on both sides to find out that secant squared minus tangent squared is equal to 1. And that is the derivative of this problem. Okay, so that was a little bit crazy. And again, takes a little bit of space, takes some thought, okay, and thinking about manipulating these trig functions in different ways to see if you can get things to cancel out, but we were able to come up with the outcome, okay? So do the best you can on those, and good luck with it. So sorry about the interruption of my children's dinner and our smoke alarm. Have a great day, and good luck on the assignment. See you soon.